and welcome to Pass the Torque. I'm your host, Katie Caudry. All week we've been collecting your questions for our NExIS Division Chief, Benjamin Reed. Today he's here to answer some of those questions. Don't forget, we do have informational bubbles pop up to let you know exactly what's going on. And for now, I'll pass it to Ben. At any point in your life, did you think you'd land here?
Oh my gosh, no. I grew up in North Carolina, in Charlotte, North Carolina. I went to West Charlotte High School, and I can tell you all my summer jobs in high school and college were working on a grounds crew of a university, cutting trees, bushes, mowing the grass. So did I think that I would end up at NASA leading a group of technologists that was reestablishing reestablishing state-of-the-art for robotics? Absolutely not. What I did was I tried to pay attention to opportunities throughout my career after college and take advantage of those opportunities when they came and learn from fabulous mentors. So no, I am extremely lucky and proud to be where I am, but it was definitely not planned out. After getting a bachelor's in chemistry, I worked for the American Dental Association for 10 years out of college, working on dental materials for teeth. So when you get a plastic filling or composite filling these days, I worked for the American Dental Association in helping to develop the materials that go inside that so they last longer, look more like your teeth, better able to resist the wear of food. So that community is constantly working on improved dental materials. That's what I did for 10 years. And it was after working there, I thought, I'm ready for a new challenge. I've been there about a decade. So I was reading the want ads in the Washington Post. There was one to work for NASA as a materials engineer. I knew nothing about space, nothing about satellites. But I went ahead and applied for the job and was lucky enough to be selected. And I've been with NASA for 22 years after that occurrence, and really, really glad that I made that leap.
Who has been your favorite person to give a tour to or have met over your years while working with NASA?
At Goddard Space Flight Center in Maryland, which is where I work, we have a very large robotics facility. This is a very large room that is filled with, I think, 12 or 13 different robots. We also have a full mock-up of a satellite that is in orbit. We also practice operations in outer space in this room, so the room is completely surrounded by black curtains. The walls are all painted black. So it is a very interesting, a very cool place to work. And as a result, we get many, many requests for tours. So in a typical year, I think we will give around 150 tours of our facility in a single year. Throughout the course of time, I have given north of 1,000 tours to groups. And there have been some interesting guests. We hosted the President of the Republic of Korea. That was a very interesting tour. That took a lot of coordination with the Korean government, with the U.S. Secret Service. That was an interesting time. We also gave a tour to the King of Sweden. That was a fun time as well. That was an interesting tour. But I got to say, the day that stands out in my mind the most was the day that I got to spend 4 hours with GZA from the Wu-Tang Clan. He now hosts a series on Netflix called Liquid Science, and he came to the lab and interviewed me, and we worked on some content for one of his episodes. So I got to spend 4 hours with GZA, and that was pretty cool, I got to tell you. So again, how did a guy who was a chemist, became an engineer, end up spending 4 hours with GZA and the King of Sweden? You just got to seize your opportunities when they come.
What policies or treaties exist that govern man-made orbiting bodies around Earth?
Okay, a space policy question. So the Outer Space Treaty of 1967 which has been ratified by, either signed or ratified by 109 countries, establishes the basis for international space law. Space is a shared resource that everyone on Earth is able to take advantage of and should be allowed to take advantage of. And so as a result, this treaty sets up a framework for all the various entities that have activities in outer space to treat it responsibly. And so the Outer Space Treaty of 1967 really is the basis that all countries follow for their activities in space.
Can you tell me about the latest projects you're working on for in-space assembly and manufacturing?
Sure. So primarily what my division at Goddard Space Flight Center is working on is in-space servicing, fixing, repairing, refueling of a satellite in space or a future satellite yet to go up. But we are also working with in-space assembly and manufacturing. We've got a mission called OSAM-1, On-Orbit Servicing, Assembly, and Manufacturing 1. So it's the first mission going into outer space dedicated to advancing the technologies of servicing, assembly, and manufacturing in space. So the question was about assembly and manufacturing. So we are going on that mission. We're going to be carrying up 7 hexagonal panels about this big each. And we are going to use a robot in space on our satellite to hook these 7 segments together to form a 25 square meter communications antenna. And this communications antenna is launching with these segments stacked like dinner plates. But when it's assembled, it'll be this large functioning object. So that'll be a world's first where an antenna is assembled from piece parts in space. So we are very excited about that. You can imagine if 7 can make something that's 3 meters across, well, you can imagine flying 70 segments and building something a lot bigger, or 700 segments. So we always look for technologies that are applicable now to present day needs, larger communications antennas, but are what we in the business called scalable. They can scale up to larger and larger and larger objects. So we're very excited to have this SPIDER payload. So this antenna demonstration is called SPIDER. It's an acronym. If you search it online, you'll be able to find out where it is. And actually, here's a link to an article about our mission right here. So in-space manufacturing. That is also a part of the OSAM-1 mission. And with the in-space manufacturing, what we're going to do is we're going to have a box about yay big, chock full of high technology, and it's going to be on the side of our spacecraft. And from it is going to manufacture in space or pultrude a composite beam 10 meters long, about 40 feet long. And so this composite beam is going to extend out from the box, and it's not just deploying or unfurling or unrolling, but we are manufacturing it in space. So we're very excited about this as well. And that technology is brought to us, both SPIDER and this in-space manufacturing, with our industrial partner, Maxar. Maxar Technologies is a part of our mission, a key part. They are integral with us with both SPIDER and this in-space manufacturing demo, which is from another company called Tethers Unlimited. So we are very proud to be working with the U.S. aerospace industry in advancing these technologies together with NASA in a partnership relationship.
Which is your favorite monster truck?
My favorite monster truck. Now that's a great question. So let me tell you the story about a young man growing up in North Carolina in the 80s. That's me. There was a guy in my high school. His name was Rocky Vercola. And Rocky Vercola, I have to give props to. He got me started on monster trucks. Rocky Vercola was the coolest guy in school. He had a huge Jeep. And he actually, I kid you not, got 2 junker cars to be put in the school parking lot. He then, when the kids were let out at the end of the day and they were all leaving, he drove around the parking lot and drove his Jeep on top of those two junker cars. He captured my heart. So from there, I started following Bigfoot. Bigfoot is an awesome vehicle. But I gotta say, as I became older, a little bit more mature, my taste changed a little bit. And now my favorite is Gravedigger. So I've got 4 fabulous kids and a wonderful wife, and we love to drive from Maryland down to the Outer Banks. And guess what? In the process of that trip, we get to go past Elizabeth City, North Carolina, where Gravedigger has their corporate headquarters. They have a little park next to the shop. You can actually stop, go out and look at some of the monster trucks there. So I gotta say, I started off with Bigfoot, but now I'm kind of a Gravedigger man.
How important is the business staff in carrying out the goals of the division?
That is a great question. So I go to a lot of school groups, and when I talk to students about careers with NASA, there's a common perception, and it's understandable, that NASA is nothing but scientists and engineers. Well, that is core to our mission success, scientists and engineers, no doubt. There are so many other disciplines, professions, skills, capabilities that are needed to get our job done. We need a communications team. My ability to communicate to you about what NASA does is only enabled by a fabulous communications team. We need a business team. Guess what? We are spending taxpayer dollars, and we want to do so responsibly. We want to do so in the best manner to take maximum value for the contributions we get from American taxpayers. And we cannot do that without the skills, expertise, dedication from a business team who helps keep track of money coming in, money going out, where should we be spending, what's the proper way to do it so that we're fair and equitable. So business team, critical to the execution of NASA's mission. Couldn't do it without them.
How do we currently use robots in space, and how will we use them in the future?
How do we currently use robots in space? That is a great question. So there are a couple of robots up on the International Space Station, and they are used to help receive visiting vehicles when they bring up new cargo and new supplies and more astronauts. They're also used to move things around if a component needs to be removed and replaced with one that is newer, more efficient, or just the old one is worn out. The robots sometimes are used to do remove and replace procedures, just as a crane would on a ship pull a container off and put a new container on, very similar to that, although the robots look quite a bit different, but similar function. There are a few robots, robotic arms on the surface of Mars. With the Mars rovers, you can imagine if you walk around the field and just take pictures, you'll learn a lot about that field. But if you had the ability to pick something up and look underneath it or to look inside it, you could learn more about that field. So we have equipped the Mars rovers with more than just cameras, but also robotics so that they can be more invasive and learn more about the Martian system. And there's a robotic arm on the OSIRIS-REx mission out to the asteroid Bennu. But other than that, there aren't any other robotic arms in space. So only a few. But there's 2,000 operating satellites in space. 2,000 satellites and 2 or 3 or 4 robotic arms. Big difference between that. And so how will they be used in the future? I need your help, the public, to help us think what are the best ways to use them. So certainly we have thought about and are working towards robotic arms to repair a satellite, refuel a satellite, make it last longer, make it bring more value to the people that put it into space. I've also mentioned assembly. Robotic arms are used to assemble things bigger and bigger and bigger in space. Not that the Death Star was really built to do good things, but you can imagine that if you want a large orbiting platform, like Space Station, but say 100 or 1,000 times bigger, you're going to need a lot of robotics to do that assembly. And so we have very near-term goals for arms. Refuel a satellite, prove that it can be done so that people can use this to make their satellites last longer. And then we have these longer-term goals. Let's go explore Mars with humans and robots working together. So all sorts of future uses for robotics.
What do you love about science?
What do I love about science? So in answering that question, I'll tell you how I got interested in science. And it all started with soap. 6th grade. In my science class, we studied soap. And the fact that grease on your hands, dirt on your hands are non-polar molecules. They're one kind. Water is polar. It's a different kind of molecule. And if you just put water on your hands when they're greasy, nothing happens because the two don't mix. Polar and non-polar don't mix in the molecular world. But soap is that bridge. Soap, one end of a long soap molecule is non-polar. The other end of that soap molecule is polar. And so one end of the soap molecule grabs the water, the other end grabs the dirt or the grease off your hand. And soap is what allows your hands to get clean because it bridges that gap between the non-polar and the polar. That fascinated me as a 6th grader. And from that moment on, I have gotten such satisfaction from learning how the world works. Because once you figure out how the world works, or one little piece of it, then you ask, well, what about this? And what about this? And can I apply that same methodology or that same thinking to another phenomenon that I'm observing in the world to help me better understand it? So I know it doesn't sound very, very exciting, soap, but that is what got me hooked on science. And here I am, now working for NASA. How great is that?
Thanks so much, Ben. And thank you for some really great questions. Don't forget to check back here next week to meet another one of our NASA engineers, and you'll have the chance to ask them questions as well. See you then.
Well, besides boating and monster trucks, my family is very active with a local Maryland animal rescue, and we foster puppies. And as a matter of fact, we are fostering 2 puppies right now. This is Shelby and Sherpa, and these 2 little guys and gals are both available looking for a forever home. This little boy is Sherpa, and this little girl right here is Shelby, and they are available. So this is how I spend my free time when I'm not thinking about NASA and outer space.